Hello, I'm Adam, a first year physics student, and today I'm going to share to you about my lab class during the lockdown. Since we learned fully online, some of you might think that we didn't have any practical class. However, that's not correct. We might wasn't able to go to the lab due to the current situation, but there's still another way around. Instead of doing normal experiment with standardized equipment inside the lab, we were tasked with a more simple experiment done using household materials and without supervisor. The first experiment that I did is about the interference of wave in a microwave. So by understanding the properties of stationary wave and knowing the frequency of the wave found in the tag of the microwave, I was able to calculate the speed of the electromagnetic wave used by the microwave, which also equal to the speed of light. From this experiment, I got the speed of light as about 280 millimeter per second. And this value is 7% lower than theory, which is 300 millimeter per second. Yet, it is still quite close considering the sensitivity of the equipment I use. The second experiment that I did is calculating the gravitational acceleration constant using a simple pendulum. After solving some mathematical equation, we can get the gravitational constant given as the equation G equal to 4 pi squared L over T squared, where L is the length of the pendulum, which I can directly measure by myself, and for the period of the oscillation, I use the gyro sensor in my smartphones and with the help of an app called 5 In my experiment, I obtained the value of the gravitational acceleration as 9.83 meter per second squared. The next experiment that I did is related to the centripetal acceleration. We know that the centripetal acceleration is equal to the square of angular frequency and the radius of the circle. So, to prove this true, I tried measuring the centripetal acceleration on different angular frequency and plot them in a graph, which also I use my smartphone and 5 and the result that I got is quite similar to the theory. Last but not least, we know that waves are extremely fast, but it's not instant. By measuring the delay of reflected sound wave, we are able to know the distance of the wave traveled. This method is called sonar. So the final experiment that I did is using sonar to measure short distance. Using this method, I was able to measure the distance quite close to the real distance. However, it still lack of accuracy and a little bit confusing due to echoes. Yet overall, all of this are a whole new experience for me, and I have to adapt to the current situation. Even though I don't have normal practical class, I was still able to obtain some experience setting up the experiment fully by myself. That's all for me. Thank you for listening.